Our next opportunities that we get to look at here is how do you factor a trinomial that now does not have a leading coefficient of 1, but it has some other variable or some other constant. My particular example right here has a 3. So does that matter? What comes into play? So let's walk through this very gently on this first one. So first of all, let's recognize a couple of things. One, I have a trinomial. Variable is x. Could have been any variable. Leading coefficient is not a 1. First of all, can I factor anything out? Maybe if I factor out something, then I'm left with a traditional trinomial. Nope, there's nothing that's common as a greatest common factor between each of those three terms. So I can't pre-factor or do an early quick factor. I can't do that. So my process is going to be kind of involved as this. I have to keep in mind what are all the possibilities that make a 3x in that first term. So I'm going to make a little bit of a side list over here. Well, that's really the only way I can make this leading coefficient is having a 3x times an x. No other way. But I put that step in there because we will find times where that's not always the case. Second step then is I want to list all the factors to make a 28. And here's I want to kind of develop a good system on my paper to help kind of make sense. So I'm going to over here on a different part of scratch paper, 28. That's a 28 and a 1 and a 28. Same thing, more or less. 14 and a 2, 7 and a 4. Let's erase that one out. And then I also have a negative 28 and a negative 1, negative 14, and a negative 2, and a negative 7, and a negative 4. So those are 6 possibilities that I have in order to factor, in order to make a positive 28. Now here's what I need to try. I don't know which one of these is because when I FOIL, remember it was a combination of the outers and the inners that produce this term and that term as well. Sorry, the outers and the inners. Since I have a different number than a 1, it complicates things just a little bit. So I'm going to make a listing of all my possibilities. Let's look at this one. I can put a 3x plus a 28 and an x plus a 1 possibility. The other possibility is a 3x plus a 1 and an x plus a 28. So that takes care of these two possibilities. The next two possibilities, let's try the 14 and the 2. 3x plus a 14 and x plus a 2. I need to check those numbers in the other situation. 3x plus a 2, 3x plus a 14. Before that did not matter. The reason why it did not matter before was because both terms had x's in it. The next ones I need to check are the 7s and the 4. Okay, those are half of the possibilities that I need to check. One thing though that you may have noticed, and hopefully maybe you got frustrated with, Willie, why are you doing all that extra work? And some of you are going, well, why is that extra work? Well, we may have learned or we may have observed over time that this middle term is a negative. So I don't have to check the numbers that are just positives because two positives when added together will not produce a negative. But I went through that process anyway. One, maybe as a little bit of a learning cue that we can be aware of that next time. And the other one is just to let you know, even if we don't, there's not that many that we have to look at. So that's one set of them. Now we have to do the same thing just with the negative numbers that we have. 3x minus 28, and an x minus 1. Flip those around. 3x minus 1, x minus 28. That's that first set. 3x minus a 14, x minus a 2, 3x minus 2, x minus 14. And then the last set is a 3x minus a 7, x minus a 4, and the other possibility 3x minus a 4, x minus a 7. So in total, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I have 12 possibilities that meet 2 of the requirements of this trinomial. Every one of these, if I were to FOIL them, would produce a leading term, 3x squared, and an ending term of 28. All of those meet that qualification. However, we're also looking for the one that matches up with that middle term, makes a negative 20x. And that happens when I multiply the outers and the inners. Good thing is, I narrowed down the list to a relatively small number. I can narrow it down further by not checking any of those positive ones, because there's no way 2 positives, when added, will make a negative. And now I just need to look for the one that makes a 20. This one makes, I have a 3 and a 28. No way to make a 20 out of that. 3 times 28 is 60, 70, 84, and a 1. No chance. 14s and 2s. I have a 6 and a 14. Okay, 6 and 14s, if things work out the right way, I can make a 20 there. So let's see. I have negative 6 and negative 14. That makes a negative 20. So there's my solution right there. And now I found how to factor and what the factor is of this trinomial whose leading coefficient is not 1.